Okay, let's continue on and let's finish up 2.7 here. Okay, applications of mean, standard deviation, z-scores, and choosing the correct measure of center and spread. Okay, let me share my screen. Okay, there we go. Okay, objectives. Calculate and interpret z-scores. Use z-scores to find unusual values or compare values and identify the best measure of center spread based on the shape. Okay, so to standardize values, we use something called the z-score, and we take our value minus the mean and then divide by the standard deviation. This kind of normalizes all of our scores. Okay, whether we're talking about 105 as the mean or 7 as the mean, this standardizes it so that the mean ends up being at 0, and then we can get a nice bell curve for our distributions, okay, or it'll standardize and make all of the distributions the same, have the same mean at 0, and the same standard deviation, which will be 1, okay, and so this calculation allows us to then compare, apples to apples. Okay, can we compare this distribution to another distribution? Okay, the z-score tells us how many standard deviations we are above or below the mean. Scores usually have values between -2 and 2 are rare, and more than plus or 3 and rare are more than plus or minus 3. Okay. Right, you usually have values between -2 and 2, -2 and +2 standard deviations, and rare scores are more than plus or minus 3. So if you're more than 3 standard deviations away, that's rare. That's pretty much an outlier. Okay, really high or really low z-score should make us worry, though it may still be correct. Okay, find and interpret the z-score. Okay, population mean is 3. The population standard deviation, find the z-score for a score of 6. Okay, so let's go z is equal to x minus the mean, which is mu, over the standard deviation of sigma. Okay, this is for a population. Okay, so this is going to be equal to 6 minus 3 over 2, okay, which is 1.5. Okay, so this is equal to 1.5. So we know that our score, okay, okay, was 1.5 standard deviations above the mean. It's a positive, so it's above the mean. Above the mean. Okay, so that was above the mean. Okay, let's look at the next one here. Here we have a sample. Okay, sample mean, other was a population. Sample z is equal to x minus, this time it's x bar because that's the mean, over s, which is the sample standard deviation. So this is going to be x, which is 4 minus 5 over 2. That's going to be -1/2, or I'm just going to go -0.5. I'm going to call it -0.5. Okay, so what does this tell me? This tells me that our score was 0.5 standard deviations below the mean. Okay. Okay, when a distribution is what we call normal, okay, 95% of the values are within 2 standard deviations. Okay, so a normal distribution looks like this. It's our bell-shaped curve. Okay, and so that we say that here's the mean. The mean is at 0. Okay, 0 standard deviations. Okay, and then if we go 1 standard deviation, 2 standard deviations, 3 standard deviations, 1 standard deviation, 2 standard deviations, 3 standard deviations. If we're at -2 and +2, we're saying that 95% of the score, okay, 95% of the score, which is going to be this area here, okay, is between +2 and -2 standard deviations. Okay. This gives us a nice range of variables that we would consider ordinary or usual. Anything beyond 2 standard deviations would be considered unusual, since we see them less than 5% of the time. Okay. So these are going to be our usual values. Okay, usual values. And anything beyond 2 or below -2 is unusual. Okay. Okay, a man measured his pulse rate at 47 beats per minute. Okay, is the pulse rate unusual if the mean adult is 67.3 and with a standard deviation of 10? Okay, so we want to know, is this an unusual rate? Is it unusually low? Okay, so let's calculate our z-score. Our z-score is x minus the mean. Okay, x minus mu over sigma, standard deviation. Okay, so x equals, 48 minus 67.3 over 10.3. Let's plug that into our calculator. 48 minus 67.3. Okay, that's negative 19.3. Divide that by 10.3, and I get negative 1.87. Okay, so this is negative 1.87. Okay, that's my z-score. That tells me that I'm 1.87 standard deviations below the mean. So 1.87 standard deviations below the mean. Okay, so again, if the mean was here, okay, at 0, then we're 1, and if this is 2, then we'd be like right here, right? We'd be 1.7 standard deviations below. Boom. And we want to know, is that unusual? No, because we're not past -2. Okay, we're not past -2, which, so it is not considered unusual. Unusual. Okay, it's not considered unusual since it is less than 2 standard deviations below the mean. Okay. Okay, on Brian's first calculus test, he scored 48 out of 100. The class average was 63.7 with a standard deviation of 7.2. Although Brian scored below average, he figures he will not drop the class unless his score is unusually low compared to the rest of the class. Would you consider his score unusually low? What is it? It's a 48. Okay, so let's do the z-score. Z is equal to x minus mu over sigma. Okay, so x minus mu is the class average, so that's 63.7. X is his score, which is 48. Okay, and then the standard deviation is 7.2. So let's calculate this guy. 48 minus 63.7, okay, equals, okay, don't forget to put the equals, okay, because we have to divide by the whole thing here. That's negative 15.7. Okay, and now let's divide that by 7.2. And we get negative 2.18. Negative 2.18. So, right, oops. Okay, and so this score, or his score, we should say, his score of 48 was unusually low. Unusually low. Okay, because it's more than 2 standard deviations below. Okay, 2 students, John and Ollie from different high schools, wanted to find out who had the highest GPA compared to his school. Which student had the highest GPA when compared to his school? Okay, so you know we're looking at John's score compared to his population or his school, and Allie's score compared to his population. Okay, so okay, so we can't compare apples to apples here because John's GPA is, you know, basically how we calculate GPA based on a 4-point scale, but Allie's GPA is calculated on a 100-point scale. So in order to compare them, we have to get they're right now they're apples to oranges. They're on different scales. So we've got to get apples to apples so that we can compare the z-scores. And now we'll standardize them. That'll make the mean be 0, and it'll make the standard deviation 1. Okay, so when we say that we have a normal standard distribution, okay, that means that the mean is 0 and the standard deviation is 1. Okay, and that's what we want to do here. We want to standardize this. Okay, and we want to find out, you know, how does that compare? How do these two GPAs compare to their individual populations? Okay, so for John, okay, his z-score is going to be 2.85 minus 3.0 all over 0.7. Okay, and if I were to plug that into the calculator, 2.85 minus 3.0, hit equals, okay, and divide that by 0.7, I get negative 0.21. Okay, so that's negative 0.21. Okay, so 0.21 standard deviations below the mean. Okay, Ollie, let's do his z-score. It's 77 minus 80 over 10. This is going to be negative 3 over 10, which is negative 0.30. So, okay, which student had the higher GPA? Well, if we look at a number line and we're at 0, right? So where is negative? If we did negative 0.1, negative 0.2, and negative 0.3, okay, then Ollie's is lower than John's, right? So who had the higher one? John. John was higher. Okay. Okay, let's explore for the following data sets. Okay, for each data set, do the following: draw a dot plot and describe the shape. Calculate the mean and median. Okay, so for the dot plot, okay, we're going to go 0, 1, 2, 3, 4. Okay, and so we have one value at 0, one value at 1, 2 at 2, 3 at 3, and 4 at 4. Okay, and so this one is skewed. Okay, you can see that this thing is skewed. Okay, and how is it skewed? It's skewed skewed left. Okay, or left-tailed. Okay, what about this one here? We go 1, 2, 3, 4, and 5. Okay. This guy, 1, 2, 3, 4. 1, 2, 3. Okay, 1, 2, 1, and there we go. And this guy here goes downhill, so that's skewed right. Okay, that's skewed right. And then what about this dot plot here? This guy is 1, 2, 3, 4, 5. So we have 1, 1, 2, 1, 2, 3, 1, 2, and 1. And that's basically symmetric. Okay, it's not skewed, it's unimodal and symmetric. Unimodal. Okay, one mode, and they all have one mode basically, so it's not quite as important, but it is symmetric. Okay, let's calculate the mean and the median. We're going to go to the calculator on that one. Okay, let's calculate the mean and the median on these. So make it a little bit easier to go back and forth here. I'll just go out like this and then click back and forth. Okay. Okay, so for first one, okay, I'm going to want 0, 1, 2, 2, 3, 3, 3, 4, 4, 4. Okay. So 0, 1, 2, 2. Basically, the number is the amount, is the items. Okay, so let's plug that in. Okay, so let me clear this. So clear, and then enter. Enter, and we wanted 0, 1, 2 2s, 3 3s, and 4 4s. Okay, so that's good. Is that true? Yeah, that's correct. Okay, so now I'm going to go to stats, calc, one variable statistics, calculate. Okay, so then we want the mean and the median, right? I'm going to, the mean is 2.72 or 2.73. Okay, so the mean is 2.73. And what's the median here? I'm going to arrow down to get the median. The median is 3. Okay, the median is 3. So the median is 3. The next one, I want 4 1s, 3 2s, 2 3s, 4, and a 5. Okay, so we're going to start off with 4 1s and then go down. Okay, so let's go back to stats, edit. Okay, and then we're going to clear this. So clear, enter. And I'm going to go 4 ones. 1, 2, 3, 4 ones, 3 twos, 2 threes, a 4 and a 5. Okay, now let's calculate that. Stat, calc, one variable statistics, and that is 2.23, and that's the mean, and the median is 2. Okay, so 2.27, I should say, 2.27. Okay, so 2.27 is the mean. The median was 2. Okay. What about this one? The next one. I think I know what the pattern is on that one. Stat, edit. Okay. Let's go up here and clear this. Clear, enter. And we're going to go 1, start with 1, and then 2 twos, and then 3 threes, and then 2 fours, and 1 5. Okay, so I think that's good on that one. Okay, and we're going to go stat. Okay, well, calc, one variable statistics, enter, 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 and it shows that the mean is 3, which kind of makes sense, and it shows the median is 3. Okay, so the mean is 3 and the median is 3. So the mean is 3 and the median is 3. Okay, compare the mean and the median each case. Okay, so the mean, okay, is less than the median when it's skewed left. Okay, so the mean is less than the median. The median is here. This is the middle number, is the median here, but the mean was less than the median. Okay, but it's skewed left. Okay, here the mean is 2.27, so it's about right here. Okay, the fulcrum is about right there, but the median is 2. So here the median, okay, is less than the median. Okay, so this was the median and then the mean. And then here, this is the median and then the mean. Okay, let me zoom this in. Okay, so this is the mean. So when it's skewed left, the mean comes first, is on the right, and the median's on the left. If it's skewed right, the median is on the left and the mean is on the right. Okay, what if it's symmetric? Well, they're the same thing. Okay, the mean, which is the little fulcrum here, the balancing of the mean, and the median, okay, are the same number. So mean and median are the same number when it's symmetric. Okay. Okay, that next page kind of sums this up. Okay, it says how do skew distributions and outliers affect your measures of center and spread? Okay, they affect the mean more than the median. Okay, they affect the standard deviation more than the IQR. The range is highly affected by outliers. That's correct. The IQR and the median are robust or resistant statistics. Okay, if it's skewed right, okay, the mean will be pulled right, so the mean will typically be higher than the median. Okay, or on the left, this is our right skewed, right? So if we have a right skewed, then the median will be higher, lower than the mean. Okay, that's if it's skewed right. If it's skewed left, like we saw, okay, if it's skewed left, then the mean will be pulled to the left. So then we would get the mean would be lower than the median. Okay. An outlier will pull the mean toward itself. Okay, so if you have an outlier out here, like way out here, and this is an outlier, the mean's going to get pulled toward that outlier. It's going to be like the gravity of a planet. It's going to pull it to that. Okay, the median will be mostly unaffected. Okay. Okay, is it both unimodal and symmetric? Common pairings of measures of center, okay, and spread depending on the shape. Okay, this has no outliers. Okay, which center and spread do we want to use if there's no outliers? If it's unimodal and symmetric, okay, then it looks like this. And so which one do we want to use? Well, for the center, I would want to use the mean. That's the most accurate. And the spread, I would want to use the standard deviation. Okay, if it's symmetric and unimodal, use standard deviation and mean. What if it's skewed? What if it's skewed? What if it looks like this? Okay, skewed data. Okay, so it looks like that. Mean and standard deviation. Okay, but what if it's skewed or does it have outliers? Okay, maybe there's a big outlier out here. Okay, what do we want to use? Well, for the center, we want to use the median since it's resistant to skewed data and outliers. And the spread, we want to use the IQR, okay, interquartile range. Okay, describe the shape, then determine which measures of center and spread are most appropriate in describing the typical value in the data set. Okay, so this looks like it's pretty much unimodal and symmetric. Okay, so it says estimate if the mean would be higher, lower, or about the same as the median. Well, here I'd want to use the mean and the standard deviation. And would the mean be higher or lower or about the same? It would be about the same. Okay, so the mean is about the same as the median. Okay, here we have, so it's skewed. So here it's skewed right. Okay, I'd want it on skew data, I'd want to use the median and the IQR. Okay, and where's the mean? The mean is going to be bigger than the median. The median follows the majority of the data, right? So if the majority of the data is low, then the median is going to be low. Okay, so again, if we're skewed, the median is going to be lower than the mean. Okay, so the mean, or we could say that the mean is higher than the median. Okay, what about an outlier? What would we want to use here? If we had an outlier, okay, then that outlier is going to do what? It's going to take that mean and it's going to pull it this way. Okay, it's going to pull the mean toward the outlier. Okay, which means that the median, which roughly is not affected by the outliers, is not going to be pulled. The median will not be pulled. The mean will be pulled. Okay, so here I would want to use the median and the IQR if I have outliers. I don't want my data to be skewed by that outlier, and the mean is going to be higher than the median again. Okay, so the outlier would push the mean too high. Okay, so the mean is higher than the median. Okay, so that's it for 2.7, and I'll see you in the next video.